Hello everyone, in this video let's talk about the interface set and the class HashSet that implements that interface. So I already created a class called book. That class has three member variables: author, title and price. It has a constructor that expects a title as argument. It has a few getter and setter methods, and it overrides the hash code and the equals method. So let's get started with our set and hash set types. I create a new class called main, and I'll generate the main method in that class. And then I create a variable of the set interface. So I want to have an interface of type book. Here I need to import this. So the set interface is in the java.util package. And as I said, this is an interface, and here we initialize it to the class that implements that interface, and this is the HashSet class. I also import this one, same package, java.util. And now I can operate on this set. So one thing that I can do is add elements to the set. And I add them using the add method. So I create a new book. Java is fun. And I create another book. And this book is called Java is Great. And let's add another book. And this book again is called Java is Fun. So now let's output the number of books in our set. So in order to get the number of books, I create a variable called size, and I call the set.size method. And then next I output this. To the console, and then let's run this. So the size is 2. I added 3 objects, but the size is 2. And this is the main purpose of a set. That a set makes sure that we don't have any duplicates. So there are 2 important things here. One, the third book is a duplicate of the first one. And the reason for this is because we implemented 2 methods in the book class. So if I go back here, the 2 methods are the hash code and the equals method. We have to override both. So if I comment these out, and essentially my book class no longer overrides these 2 methods, and I go back to the main, and I run my code again, what will be the size of the set? So let's check this out. Now we get 3. Why do we get 3? Because we added 3 objects and we didn't implement the hash code and the equals method in our book class. And so what the set will do is it will use references to compare them. And the references here are different. This is a different object than this one. Now if I only implement equals, so let me only implement equals, and I still comment out the hashcode method. So implementing the equals for an array list or linked list is sufficient. But when we talk about sets or hash set or hash map, we also have to implement and override the hashcode method. So we'll see if I run this again. It will still be 3. It doesn't work yet, even though we overrode the equals method. So it requires also overriding the hashcode method. And now if I go back here, I run it, this should give me the right number 2 for the size. So the way a hash set works internally, it actually is a hash map. And so we need the hashcode function to digest our object into a hashcode and then map it to a specific spot in the hash map. And if we don't provide the hash code function, these two objects will be mapped to different positions in the hash map. So they don't get treated as the same object. If we override the hash code function, they get mapped to the exact same spot in the hash table, and then the equals method will determine if it's actually the same object or if there was a collision between two objects. So really to sum it up, how hash tables work is you have a hashcode function that maps to a specific position, and then there can be conflicts. Maybe two objects just happen to map to the exact same position. So somehow we have to determine, is there a collision or is it just the exact same object? And to determine that, whether or not there's a collision or if it's the same object, Java uses the equals method for that. So if the equals method returns false, there's a collision. We have to somehow store both objects at that position. However, if equals returns true, there's not a position, I just try to replace that object, or I actually want to get that object or check if it exists. So to sum it up, we have to override both hashcode and equals. And if you're not familiar how to override these two, you can watch my other video on hashcode and equals method. So back to our set, we can check if an object exists by calling the contains method. So we do set.contains and we pass in a book that we want to check. So I create a new book, Java is great. Should be the book constructor here. And let me actually do that again. I copy and paste this line. Another book, Java is awesome. And the next thing is I print out both of these. So I'll check if Java is great exists. And next I output if Java is awesome exists. And I run this code. So Java is great exists, that is true. The other one doesn't exist. And another way, we can also get the object inside our set from an object that we pass in. So let's say, for example, I create a new book here. Call it B. I call the constructor Java is fun, and I set a price 100, and I set an author, pass in Ryan, and now what I'll do is I create a variable called found, and I call my set.get So then let's talk about how we can iterate over a set. So one way is to use an iterator, and we iterate over book objects. And to get the iterator, we call the iterator method, and then we need to import it. It's in the java.util package. And for the iterator, we call .hasNext. So as long as there's another object, let's get the other object, and we get it by calling java.next. This will do two things. It will return the next object or the current object and move the iterator along by one position. So if we run this, we get two book objects. I didn't override the toString method, that's why we just see it the way we see it here. Now we can also use a for each loop for it. So for every book in our set, we want to do something with this book. In this case, we just print it out. So this will be the for each method, and I output this before. And internally, this actually uses an iterator. So it's probably more convenient to use the for each method. That way we don't have to write the boilerplate code around it. So let's execute this. And you can see we get the exact same output. So either one of them is fine to iterate over a set. So let's also see how we can remove an object. We can remove it by calling the remove method, and we pass in an object that we want to remove. So I create a new book here. Java is fun. And the nice thing about the remove method, it actually returns a boolean. I call this was removed. And this will be true if it was found and removed, and false if it wasn't removed. So I output this here, was removed. And then I execute the code one last time. So we can see we had two books before when we ran it with the iterator. Two books here. Then I removed one book. This was successful, I got true. And when I iterated over it again, there was only one book left in the set. And that is everything about hash sets. I hope you enjoyed this video. Thank you for watching.